2018 question number 1, which is a calculator question. So when you read the question, it should have sounded very familiar to you because it's another one of those examples where you're given functions that represent the rate that something is going in and the rate that something is going out. Just in the FRQs that we've been doing recently to practice for the AP exam, you've seen this scenario multiple times, whether it's, remember there was people going into a rock concert and they gave you a rate and asked you questions. We've talked about so many about the Camp Newton, water going in, water going out. Here we have people waiting in line for an escalator, and we have an equation for the rate that people are getting into the line. So this is the rate in. They're entering the line for the escalator. Now from time equals 0 to 300 seconds, this is our equation. It's kind of nasty there. But apparently from 300 seconds and beyond, nobody's getting in line. So you have these 300 seconds where a lot of people are getting in line, and then after that, nobody's getting in line. So in my mind, I'm visualizing something like, you know, if you've ever been to New York, you know, like when a subway comes in and the doors open, all those people come out, and then they get on maybe the escalator that goes, you know, up to street level, then you're going to have a long line at the escalator. But then once all those people ride the escalator, then it's not going to have anyone in line for a little while. So there's, or, you know, when you come in on an airplane and everyone gets off the plane, maybe there's an escalator there, you know, to go to get your luggage. Everybody's in line because they just got off the plane, and then once the 300 seconds is over, now nobody's in line. So this is that rate, but then it also tells you that as people get on the escalator, they're going to exit the line because they're getting on the escalator, so they're not in line anymore, and that rate is 0.7 persons per second. So that's kind of a constant. So the rate they're going in from 0 to 300 is this equation, and the 0.7, that's a constant. That's just like, you know, E of t equals 0.7. So if you want to call that an equation, you can just say E of t, that's like S exiting the line, is simply a constant 0.7, which that's a function. It's just a constant. It's just going to be easy to type. And then also note that there are 20 people in line at time equals 0. I'm sure that's going to come into play somewhere. I bet they're going to ask us how many people are in line at a certain time. All right, so part A says, how many people enter the line during that interval from 0 to 300? Well, that has absolutely nothing to do with people getting out of line. That's just saying, in those 300 seconds, when everybody comes and gets in line, how many total people got in that line? Well, total is your key you need to integrate. When you integrate a rate, you get the total. So part A, you should integrate 0 to 300 r of t dt. And if you're going in the interval from 0 to 300, that of course is this equation. That has nothing to do with the 0. That's just this equation you're going to integrate. Isn't that always part A? Part A always asks you at a certain time how many people are in line, how many people have come into the rock concert, how much water has gone into the tank. It always asks something like that in part A. So you're going to integrate. So this is all you would have to write. You'll see when you look at the rubric, you're going to get a point for setting up your integral. Now, on your calculator, and you would have already done this before you even read part A, I would go ahead and graph the r of t and my e of t. And then I also know, since people are going in or people are going out, I probably am going to need to also have r of t minus e of t as well. So I've already typed those. So y1 is r of t, and that's just from 0 to 300. y2 is e of t, which is good from 0 to 300 the entire time. But then I also went ahead and did y1 minus y2, which is the rate people are going in minus the rate they're going out, because I'm sure at some point they're going to ask me at a certain time how many people are currently in the line, which would mean you'd have to add all the people that got in the line and then subtract all the people that got out of line, and that's why I have y1 minus y2. Now for part A, I just need to integrate 0 to 300 r of t. So I'm going to do that on the home screen. I just like it on the home screen. You can do it on the graph. Just graph y1 and then do second calc choice 7, I think it is, right? choice 7, integrate 0 to 300. Or you can do it here on the home screen. Math, choice 9 is your integral. Go 0 to 300. And that's y1. So remember, there's a shortcut for that in F4. I can do second F4 and grab y1 right there. Or, for some reason, I like the old method just because that's what I'm used to. I usually just do vars. I go over to y-vars. It's a function, and I pick y1 there. dx. Hit enter, and you get a nice pretty number. That was well rigged, wasn't it? So that is 270. And so my answer would be, from time equals 0 to 300, there are 270 people. It doesn't really ask for any units or explanation. I'm going to write people, but they're not going to ask for that on the rubric because it didn't ask you for units. Remember, you only have to give them when they ask. So that's part A. Now, if you want to do it on the graph, you're going to have to set up a window. Now, since this is good for 0 to 300 seconds, I would do on the X window 0 to 300. And I counted by 50s because 300 is kind of a big number. Now, I knew to go -5 to 5. I guess I'll do a scale of 1 there, only because what I did to set that up is I looked at the table. I kind of looked at some values, and I noticed that the values are pretty small numbers. Here, oh, that's y3. Let me turn on y1 for you there. And y2. Here's y1 and y2. So again, though, I look at the table, and I noticed the values from 0 to 300 are quite small. That's how I knew to go -5 to 5. I like to put my x-axis right in the middle of the screen. And so here is r of t, the rate people are going out. And then you'll notice a horizontal line. That will be e of t, which is a constant, 0.7. Now, if you want to integrate on your graph, all you have to do is second calc choice 7. Now make sure that you're on y1. Notice right here you're on y1, and just go 0 to 300. Of course, it's going to shade it all in. It's going to give you that same answer, 270. So however you do it, the answer for part A is 270 people have entered the line in those 300 seconds. Now, of course, some people are also getting out of the line. Now, part B. Part B says, during the time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time equals 300? So think about everything that's going on here. Number one, there's already 20 people in line before you even begin. So at time equals 0, there are already 20 people in line. But then you have to add what goes on from time equals 0 to 300. Well, people are getting in line from time equal to 0 to 300, and people are getting out of line. So I'm just going to set up a single integral to show all that. So I'm going to do 20 plus, and then I'm going to integrate. I'm going to go from 0 to 300, and I'm just going to integrate r of t minus e of t, and I'm just going to write 0.7 unless, if I write if I write this in my answer, I can use e of t, but 0.7 is just as easy to write. This would tell you the total number of people. Now there's other ways of doing it. You already know the integral from 0 to 300 r of t is 270. So you could do 20 plus 270 minus the integral from 0 to 300 of 0.7 dt. You could do that as well. So there's other ways of writing that since you already know the answer. I'm just going to do it all as one integral. I'm just going to type that on my calculator. Now there's lots of ways of figuring it out, but I would just do this. Back on the home screen, I'm just going to do 20, that's the number of people that were in line before I started, plus math choice 9, the integral from 0 to 300. Now remember, r of t was in y1, so I do vars, y-vars function y1, or use your shortcut, minus, I could type y2 here, or I can just type 0.7 dt. They're all just as easy to type. And here's your answer. That would be 80 people. So at time equals 300, there are 80 people still in line for the escalator. So what happened, of course, is whatever happened, whether they got off the subway, got off an airplane, whatever, a whole bunch of people just arrived at that escalator very quickly in 300 seconds, and they're getting on the escalator at a slower rate than they're getting on, and so at time equals 300, there's still 80 people waiting to get on that escalator. Now we get to part C. For time greater than 300, remember, for time greater than 300, nobody else is arriving to get in line for that escalator. So we know at exactly time equals 300, there's 80 people still standing there waiting to get on the escalator. Now, from 300 on, what happens? It says, what is the first time that there are no people in line for the escalator? Well, let's think about it. At time equals exactly 300, there are 80 people standing in line. Now, what happens after time equals 300? Nobody else gets in line, but people are getting on the escalator, thus getting out of line. So you have to subtract the people getting on the escalator. Now, you don't really need an integral for this because the rate they're getting on the escalator is 0.7 people per second. So you can figure out how many people get on the escalator if you just take the rate 0.7 and you multiply by the number of seconds. So like in 1 second, 0.7 people would be on the escalator. In 2 seconds, 1.4 people would have gotten on the escalator. In 3 seconds, that'd be 0.7 times 3, and so on and so on. So I'm just going to do an algebra equation. I would take 80 minus the rate they're getting on the escalator times the number of seconds that have passed. And when there's no more people in line, that would equal 0. That is just a basic little Algebra 1 equation. That's all you need. Now, if you did the integral, 80 minus the integral from, it would have to be like 0 to x 0.7 dt, I think you're going to make your life a little more complicated. I think this is much easier than trying to use an integral to solve it. So now I just get 80 equals 0.7 t. So t would be 80 divided by 0.7, so just do 80 divided by 0.7. Whoops, 80 divided by 0.7, and you get 114.286 seconds. Now, here's the tricky part, because it might be tempting just to leave that, but it says, what is the time? This is the time after the 300 seconds. So it's 114.286 seconds after the 300 seconds. They want you to add those two to get the grand total of time. So add 300, it's actually 414.286 seconds is the answer. I would suspect some people probably forgot to add the 300. They just said, oh, at time equals 114.286. Well, that's the time after the 300, so you needed to add the 300. I think that's a little bit tricky there. Now, part D. Now, read this one, and again, that's such a common question. From time equals 0 to 300, closed interval, at what time is the number of people in line a minimum? Now, it doesn't say absolute min, but it has a closed interval. A closed interval paired with an extreme word, whether it says absolute or not, they're asking you for an absolute minimum. Again, the closed interval is the clue. This is EVT in part D. Now remember, for EVT, what are the times you need to check? You're going to need to check some times, and you need to know the number of people who are in line at those times. You're going to check the endpoints at time equals 0 and at time equals 300. Hey, you already know those two answers. At time equals 0, you knew there were 20 people. And you already figured out in part B that at time equals 300, how many people are in line at time equals 300? 80 people. Now you just need a time in between. Now this would be a critical number. Now remember, the rate that the line is changing is r of t minus 0.7. That's the rate that the number of people in line is changing. You need to figure out where that is equal to 0. That's going to be a critical number. In other words, you're kind of looking for the tipping point. At what time do you have the number of people getting in line And the number of people getting out of line, when is that going to have to equal 0? So now when I look at the graph here. Now, I'm going to graph both r of t and the e of t 0.7. Oh, let's get rid of some of that shading. To do that, I'm just going to type a 4 over that. 4, I didn't change it, but my calculator thinks I did. Okay, this is the rate people are getting in line. And then you're going to see the rate that people are getting out of line. Getting on the escalator, that's going to be right here. Now notice this is what I'm calling the tipping point. Right here, notice, at first, the rate that people are getting in line is less than the rate they're getting on the escalator. So from this time to this time, the line would actually be getting smaller. Remember, there were 20 people to start. The line would be getting shorter here because they're getting on the escalator faster than they're getting in line. But from this time until this time, notice the rate they're getting in line far exceeds the rate they're getting out of line and getting on the escalator. So from here to here, the number of people in line would actually be increasing. And then starting right here, notice the rate they're getting in line is less than the rate they're getting on the escalator, so the number of people in line would be decreasing until, of course, we know it finally reaches 0. So the time I think we're really interested in is this one. Both of these are critical numbers. Now, if you graph r of t minus 0.7, that would be what I have in line 3, y1 minus y2. If I look at that graph, notice it's negative, then positive, and then it's going to switch back to negative. This is the rate that the number of people in line is changing. The number of people in line is decreasing, then increasing, then decreasing. If the number of people in line is changing from decreasing to increasing, this would be a min. And then when the rate is changing from increasing to decreasing, or the rate is positive to negative, this would be a max. This is the one you need right here. Now you can give them both. On the rubric they have them both, but you'll notice the only point you're given is for this first one. Now remember, I counted by 50s, so it's somewhere between 0 and 50. So I'm going to find the 0 between 0 and 50, and I get 33.013. So this would be at time equals 33.013. You can give the other one if you want, but it's not required. Now all you need to know is how many people are in line at this time. Well, go back and do the same thing you did in part B, but instead of using this time, use 33.013. So that would be 20, that's the people in line to start with, plus the integral from 0 to 33.013, the number of people coming into the line minus the number of people getting out of the line, dt. That will give you your answer. So now back to the calculator. I can just do 20 plus math choice 9 goes 0 to 33.013. Now remember, in line 3 I already typed r minus e, or r minus 0.7. So I'm just going to do vars, y vars function y3 dx, and I get 3.803 people. That's definitely the lowest of these three numbers. So my answer is at time equals 33.013 seconds. That answers this part. At what time t is the number of people in line at a minimum? There's my answer. Then to the nearest whole number, find the number of people. So I would say there are, nearest whole number, that's going to be 4 people in line. I think they're asking you to round to a whole number just for accuracy's sake, because this might have a little accuracy issue since I rounded this to the nearest thousandth. This may be off by 1,000th because, you know, I use a rounded answer to get another answer, but rounding it to a whole number kind of covers that error. So 4, no matter what you rounded this to, your whole number is still going to be 4. And so this would be my final answer then for part D. Somewhere in my work I'd probably write by EBT. It's not required, but it's certainly good to know, or let the writers know, or the readers rather know, that you knew that that's what you were supposed to be doing. Again, look at this problem, study this problem, and go back to some of the other ones that we've done. It's such a common scenario. Maybe they'll give you something like this on your exam. Now, there's only 4 parts here. They may ask you more, though, because your first question on your exam is going to be slightly longer. Now, they say you don't need a graphing calculator for the exam that you're taking, so all these calculations you wouldn't have to do, but they might ask you to explain how you would do it, or just ask you to set up the integral but not actually evaluate the integral. Maybe they'll ask you to do that, even though they're not going to ask you for specific answers.